Thank you for being here with me. I'm here to talk about some stories about use case around the world, and I'll start with a nice example from Notre Dame de Paris, kind of famous one. A quick introduction about myself. First, yeah, as you can see, I've been in the 3D scanning business since the last century. It's been around for a very long time. I changed a little bit over the years, as well as the technology, but I'm back now in France, in my home country. But thanks to all this, I will tell you some stories about 3D scanning around the globe, but also over the history of 3D scanning. Let's have some good times, hopefully. So what is reality capture? I'm sure you all know that, but I always like to say that reality capture is, if a picture is worth 1,000 words, reality capture is worth 1,000,000 pictures, basically. So you need to explain anything. Everything is visual. You have a point cloud, a 3D model. You can extract everything you need. So that's an example from our office in Joinville-le-Pont in France, and from an image, a point cloud, and the 3D model built in a Trimble SketchUp, for example. And talking about applications, I'd like to share with you my first ever project I did in 1997. We developed a scanner called the Swazik in France in 1992. It was developed to scan nuclear facility, to scan areas that are not human-friendly. It means you don't want to go there at all. So we developed that technology to scan into nuclear facility to make what today we call digital twin. But back then, there was no name for this, basically. And we applied the same technology. So it was a cave under the water in Marseille with prehistorical paintings. So no one can visit it. So we sent a scanner under the sea with some special professional divers. They collected the point cloud. And then I made a 3D model, texture with images, to make some virtual reality back then in the 90s. I'd like to share a few applications where reality capture or 3D scanning is used today, or what you can use. From a regular application, from cadastral, topography, but also from defense, mining, utilities, and you name it. So I picked a few examples into all this to share some examples with you what people did or people are doing today. The first one is like a worldwide example. For example, to make some as-built concrete slab. The first thing you need to do is to capture some accurate data. And with our scanner, because that's very accurate leveling, and a laser pointer, you can GRF your data straight in the field. Then we have the software corresponding, like FieldLink or Perspective, to make your surface inspection in the field, right in the field. And then you can see some defect. You can click on the map, turn the laser pointer to that area. People can mark the cut and fill information straight in the field again, and produce some reports. So really it's changed the way people were working to make those concrete slab, because they had to pour the concrete and then wait, try to assume. This is made in the field in real time, so changed their life in a way. I picked that second example from UK, Luxembourg, Germany, and Spain. Different stories. And the first thing is to make some pavement to identify. The screen is very small here to read, and I'm getting old too, so I have to turn my back, I'm sorry. For pavement issues and obstacles, so using like some mobile mapping system. And here what I want to explain is that reality capture is not an end. It's a mean to a result. And it means that at the end goal is to make some accurate paving and grading with a grader, dozer, total station. So I think it's important to know that it's part of a full workflow. Reality capture is not the answer to everything. It's part of the answer sometimes. So I wanted really to indicate that workflow where you have to take into consideration GNSS, mobile mapping, total station, all those things together to get to the result that the customer needs. The next one is, I love that example, it's from the UK, from a very nice company called Benchmark Surveys. They were asked to survey like an old medieval tunnel below the city, but at the same time they had to connect the above with the below. And sometimes it was very narrow, as you can see here. And like manufacturer people will tell you like everyone can scan, which is true, but not everyone can do very complex job. When you have to set control points, you have to assign everything. So if you're like surveyors, you have a big impact for the accuracy to guarantee the results are accurate. And I really wanted to emphasize with that example that everyone can scan, but not everyone can scan complex projects and do it right. And that's key. So your expertise is key in all this. Whatever you use. Trimble is better, of course, but whatever you use, your expertise is very important. If you know that flag, well, it's written on the screen, but that, an example I love too, that's why I pick all those examples, it's from Lithuania. They were doing some construction and they found that like an old water treatment station, it was demolished. And then they wanted to rebuild to see what was the condition in all this. It was made by some archaeologists. Archaeologists are not surveyors. So they use our scanner because it can register all the scans together automatically in a nice way. So connected all the data. And then what they had to do is they had some old blueprints. And then you Trimble SketchUp to rebuild all this in 3D. And then we have a solution for augmented reality called Side Vision. So they could basically bring the design of how it was before, thanks to the blueprint, bring it to the field, thanks to the GNSS, so being very accurate, plus the point cloud, all this, and the result at the end you can see. I just take a quick sip. That's a postcard from 1910, and that's today with the augmented reality model on site. So it was good, very good for preservation and all those things for them. Last one is close to my heart. It's difficult to say in English heart for a French guy or French person. It's a cathedral, I will not name it, but in that famous cathedral in France, they use like total station to do some monitoring. So they measure like hundreds of prisms inside the cathedral. But then they wanted to know what happened between all those prisms. What can we do? So they decided to also do some 3D scanning too, to be a very nice complement. So again, reality capture is part of the equation for monitoring. They're also doing some monitoring, but also here, it's important to have a scanner that can resect to control points too. If you want to compare apple with apples, you have to be in the same coordinate system, the same control points. That was also the key for them. And then also they made like a 3D model as built using the point cloud at the end. It's an example here I want to share between field to finish. It was in Saudi. We built the design in the office of the tunnel. Then we can bring the design in the field. So the instrument can see through the camera the design. We do a resection first. And then when you turn the instrument to the walls of the tunnel, you can see in real time the cut and fills information. So people can mark straight on the tunnel. And then, of course, they wanted to do some scanning to compare cut and fill information. But the thing that we had to remember that at the end, they wanted paper reports. So they don't care what we used before, but it's important for them to have something that's fast, accurate, that they can rely on and do some QA/QC as well. So that was the key here. And while I was in Saudi, it was pretty nice scenery, and I wanted to take some pictures, and because I'm a geologist, and after all, I had the scanner in the car, so we stopped, did some scanning. It's better than a picture after all. And from this, do some analysis that we could use. It was a fun trip, actually. So from tunnel to some type of geology. That one, I don't know if you heard about those type of application. It's like a windmill transport, like swept path analysis. So when people have to transport like big windmills through a type of roundabouts, below tunnel, but also below a bridge and above a bridge. For above a bridge, you need also if the bridge will sustain the weight of the convoy too. So you can do some monitoring, use total station also in parallel. And if you have to go around like some telecom towers or inside the tunnel, so being able to plan all this is a key aspect of reality capture as well. Construction control, different example from Chile, France, UK, and China. Where when people are building, could be like a nuclear facility. I cannot show example for confidentiality reason, or a supermarket. People can also bring the design in the field and compare the status of the advancement of the construction of the site. Also, of course, because we're talking about scanning, do some scanning, make some inspection map in the field again, to be able to fix potential issues straight in the field again. That example, I love it. It's me when I was a bit younger. That's in Lebanon. They wanted to scan like a oil tank to compute the volume. What they were doing was to pour water. It's called water filling technique. So lots of water, it takes a lot of time, it's not very green. And most of the time, it's not very easy to go inside. It's very clean, as you can see. It's a very nice place to go. I really enjoy a lot. And the surface to scan is brilliant. It is brilliant. It is very dark. So you need to have the right instrument to be able to capture all that information. Otherwise, you go and you capture nothing. And at the end, so we did the scan like in 10 minutes, went back to the office, I computed in RealWorks, we have a tank application, a volume, and then they talk in Arabic. They look like very angry at me, and then they asked me, do it again. So I redid the computation, that was the result, and the difference was 0.001%. So it took us like 30 minutes to do the job, compared to putting water in the tank, removing the water. So of course they use reality capture now. It's much better for them. And of course after you can do all type of inspection if you want. I'm nearly finished because there are lots of booth party and I know you all want to go. Just bear with me a little bit more. I will not be too long. I don't know how much time I have left, but this one is an example. I will have a question for you. It's an offshore rig in Nigeria. So you can see a picture from the offshore rig. They had to replace a big pipe. And they had to bring those new pipe by helicopter. So better be sure it's going to be fitting. We did the scans in 2 days. Did a 3D model for them to replace. And then they could use it for virtual reality application. So very nice. Can you imagine that that project was made in the year 2000? And we collected 1.5 million points in 2 days. That was enough to make a 3D model. So maybe today it looks funny. That was 25 years ago. But let's imagine 25 years from now, what people will say about what we are doing today. So I just wanted to share that example to show that the evolution of technology is going very fast, but still back then we could do some very nice job too. So just to finish, I have... Oh, no question. So some shipbuilding application where people, they have to check the different pieces, elements they have to build to be like a nuclear, or sorry, submarines or ships and so on. And we have tools, again, using augmented reality to be able to inspect those pieces in the field right away to fix potential issues, make report, because always whatever we use, people want a report at the end, most of the time. Also application for ballast applications, as you know, like retrofitting, revamping inside big ships. So reality capture is really the key answer for them to do this compared to traditional techniques. But also, I discovered a new application recently where people have sometimes to measure like the location of sensors on the hull of ships. I didn't know about that after all those years. So it's good to see that new applications are coming up every day. And the last one, stockpiles. It's not very exciting, stockpile. Why am I talking about stockpile? Because for the safety aspect, we have a tendency to forget that 3D scanning is exceptional for safety of all of us. There is too many accidents, and those technologies can really save life. And that's an example of if you have to scan some phosphate. It's very bad for your lungs. Don't go there. It's better to have a scanner scanning for you to compute volumes. Same for construction site, scrap metal. I did a few. It's better to be remote, like we used to call remote sensing in the past. This is really like a 3D scanning. And after having all the tools to be able to extract those volumes nearly automatically using like AI, for example. I know it's a buzzword. we use AI, but we need to extract accurately all those information. And just for the fun, I don't know if it's fun, but it's fun for me, before the booth party, I just want to share some example from when you have to go into a sewer. You have to go into dirty places. You have to do some daredevil setup, very dangerous. Acrobatic things. So example from the world, just some pictures to share with you about what people are doing. Let's say you want to go into those places. In some countries, could be some snakes, some spiders, crawling animals, French person hiding inside, you never know. Better to send a scanner than yourself. Example like this inside an office. Just some, maybe funny for some of you, a bit for me. Inside a car for forensics applications. That's in Florida, to scan like a building facade. Better to put a scanner that way. That's in Germany, they love to scan curbs like that. Only in Germany, but they love it, so that's good. And they like the result, so wonderful, or wunderbar, I should say. That's an example from Spain. Those people are very brave to put their instrument in such a location. In Australia, below a bridge. That's in Denmark, into a tunnel, you don't want to send anyone, so they place the scanner onto a robot, because it was not nice at all for human beings. I will not give the details. And just a few ones, an oven in Spain. Mobile mapping in New Zealand. Kind of Lord of the Rings mobile mapping. I don't know what they do, but they love it. When you see those people in Brazil, it's not a good sign. It means something bad happened. But the beauty of 3D scanning is to be able to record all the evidence quickly, to be able to reopen the road also to the public. Also for the police to make sure they collected everything they needed. And that apparently that was a very bad place below a supermarket. And I think I am done with some funny or strange applications from a milk cooling tank. I don't know if you have that type of project. It's a booming market. If you're looking for a new market, milk cooling tank could be a good application for you. Amusement park, lightning studies into a Dutch village. This is the Eiffel Tower. This is the instrument for scaffolding. And the last one is also close to me. I'm from the ocean. A lot of erosion right now. Buildings are collapsing and so on. So really take also like a key thing for all those type of application. And I can just finish by saying, I always like to finish on time, and I think I am on time. The only limit is really your imagination for all type of application where you can use reality capture 3D scanning. And thank you very much. Merci.